So the objective of this video is to understand how to integrate using partial fractions. This is just going to be a really short video talking about partial fractions and then integration. So if you're not familiar with partial fractions, it basically says if I have an expression, say cx plus d on x minus a times x minus b, if I have an expression in this form, I can write it as the sum of two fractions using the factors of the quadratic on the denominator. So a on x minus a plus b on x minus b. So if I'm given an integral of some expression that looks like this, I can actually write it as the sum of these two integrals, and it'll help me solve it. So I'll just get right into a question. I have 5x minus 4 on x squared minus x minus 2. So the first thing I want to do is factorize the bottom. So I'll write 5x minus 4 on x squared minus x minus 2. That's equal to 5x minus 4 on factorizing this. I believe it factorized to x minus 2, x plus 1. So I know that this expression can be written as a, some number, on x minus 2 plus b, another number, on x plus 1. So if I have just this, if I focus on just this, then if I multiply both sides by the denominator here, I'll get 5x minus 4 equals, so if I multiply this term by the denominator here, my x minus 2's will cancel, and it will leave me with just ax plus 1. And then if I multiply this term by the denominator here, my x plus 1's will cancel, and I'll just be left with x minus 2 multiplied. Right? And then if I expand this, 5x minus 4 equals ax plus a plus bx minus 2b. And if I collect like terms, I'll have a plus b of x plus a minus 2b. And this will equal 5x minus 4. So I'll take this and I'll say, okay, a plus b equals 5 because the coefficients need to be the same. And then a minus 2b equals negative 4. If I call this 1, call this 2, I'm just going to eliminate a using simultaneous equations, the elimination method. So if I do 1 minus 2, I subtract 2 from here, I'll get a minus a, and then that's 0, b minus minus 2b, so that'll be 3b, and then 5 minus minus 4 will be 9. I get b equals 3, and I'll have a equals 2. So now I can write this integral as the sum of partial fractions. So I'll have the integral of this equals 2 on x minus 2 plus 3 on x plus 1 dx. So I can split this into the sum of two integrals. This is 2 on x minus 2 plus integral of 3 on x plus 1 dx. This needs a dx. And then if I evaluated each of these, well, if I have 1 on x plus or minus something, that integral is log. So this expression is just 2 log of the denominator, 2 log e, and then mod of the denominator, because when you integrate hyperbola, you need the modular sign. Then you'll have plus 3 log e x plus 1, and then plus c. And then I could use this as my final answer, or I could use some of the log laws to express this as a single log plus c, but I think this looks nicer, so I'll leave it like that, unless a question states it wants it as a single logarithm. Moving on to just another example, doing another example, I have 2x plus 8 on x squared plus 4x plus 3. So I want to write the denominator as a product of factors. So factorizing this quadratic, I need two numbers that multiply to 3 and add to 4. So I know 3 and 1 will work. And then this will equal a on x plus 3 plus b on x plus 1. So now I'm focusing on just what I have here, and I'll be a bit more clear than my previous question. So I'll actually show the multiplication. If I multiply both sides by the denominator, I'll get 2x plus 8 on a times the denominator divided by x plus 3 plus b times the denominator on x plus 1. So then my x plus 1 cancels, my x plus 3 will cancel. We'll get 2x plus 8 equals a of x plus 1 plus b of x plus 3. Again, I'll expand it and collect like terms. That's an a. Oh, that's really ugly. ax plus a plus bx plus 3b. So I skipped a step there. I need to collect the terms. A plus b of x plus a plus 3b. So a plus b equals 2. A plus 3b equals 8. So again, if I do 1 minus 2, this is 1, 2. 1 minus 2 gives me a minus a 0. B minus 3b is minus 2b. 2 minus 8 equals minus 6. B equals 3. Therefore, a equals -1. So now my whole integral is, instead of 2x plus 8 on x squared plus 4x plus 3, I can write it as 3 on x plus 1 minus 1 on x plus 3. And I can split it up into this 1 on x plus 3 dx. So again, it's a log. This will become 3 log e mod x plus 1, and then I'm subtracting log e mod x plus 3 plus c, and I can express this as a single logarithm by using log laws. So this 3 out front can become a cube on the inside. So I can write log e mod x plus 1 cubed minus log e mod x plus 3 plus c. And then when I subtract logarithms, I divide the insides. So I get log e modulus x plus 1 cubed, and I can just combine the modulus signs. There's nothing wrong with that. So this will be x plus 3 here, and then plus c. So I've just combined these two logs into a single log, and then this is my final answer for the integral of this. Okay, so that's all for partial fractions. I hope this video was helpful for you.